This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Get to know Proximity Malt. We malt superior, European-style, low-protein varieties grown close to home in Delaware and Colorado. Domestically grown, precisely malted to style. With our team of seasoned experts and 2 brand-new malt houses, try what's really new in malt. Check us out at www.proximitymalt.com.
This has been a pet peeve of mine for 25 years, and I've been hammering on growers that don't overdry your hops, and they say, okay, fine, great, tell me how. After all these years of complaining to growers, I have a solution to the problem. Is it perfected? No. Can we adjust it to make it competitive in, 3-5 years? I think that's a pretty easy thing to do if there's a commitment to do that. So I'd like to get people in the industry, excited about it.
This week on the show, you'll learn about traditional hop drying's inherent risks, quality problems, and fire hazards. You'll hear from a Wisconsin grower who built a better mousetrap and an industry veteran who has laid out a comprehensive comparison of hop drying methods. All right here on the Master Brewers Podcast.
Hello, I'm Val Peacock, and I'm an independent consultant and owner and president of the firm Hop Solutions Incorporated, also known as HSI, and we're located in Edwardsville, Illinois.
Hello, this is Bill Arendt, owner and operator of Gorse Valley Hops, located in Nakusa, Wisconsin. I also farm 150 acres of cranberries as well.
Drying is the most critical process on a hop farm. Why is that? What are the symptoms and dangers of over-drying hops?
Well, let me start with a little bit of background on me. In my previous life, I was the head of all things technical concerning hops for Anheuser-Busch for about 20 years. And in the early 1990s, one of the main things that I noticed that caused problems with the hops that we accepted was that we rejected an awful lot of hops that were over-dried, and that was our principal complaint with number one quality problem with hops. And the problem with over-dried hops is back in those days, the brewery was using baled hops, not pellets or extract. And baled hops, when you over-dry the hops will usually, they're over-dried and they're very brittle. So that when you bale the hops, the cone loses its integrity, and what happens is that the lupulin glands that contain the alpha acids in the oil are ruptured, and the lupulin gland protects the alpha and the beta and the oil from oxidation. So these bales would not store well, and as hops get older, the bitterness becomes, more lingering and less pleasing to the palate. And this was a bad thing, especially when you're making a lager beer that you want to be smooth on the tongue. In terms of safety problems, if you do not dry hops enough, then they're sort of like baling wet hay. and you have the danger of spontaneous combustion. And I think there's been about 4 warehouses that have been burned down in Yakima in the last 25 years because of improperly dried hops, and a number of kiln fires as well. The other problem with over drying is when you dry down the hops more than you wish to, you're also driving off the oil, and you're losing the aroma of the hops. And this is one of the primary things that craft brewers want, because most of the hops that they buy, they're using for dry hopping, and they're trying to get these essence oil compounds into the beer. And if you drive them off in your drying operations, well, then they're not going to like your hops. So that's the danger of over drying, not only a safety concern, but poor storage of the hops, and you're losing the oil. And so this is why you want to get the hops dried precisely into this 10% range. You don't want them to be 15%. You don't want them to be 5%. And that's really hard to hit with the equipment that we currently have in the industry in the United States.
Okay, well, let's talk about that equipment, because there's probably some listeners who aren't familiar with the hop drying process. Why don't you tell us how they do it in the Pacific Northwest?
Okay, a standard operation in the Pacific Northwest would be a box that's going to be about 35 feet by 35 feet with a grate on the bottom, and they pile the hops into this box, and they'll pile them anywhere from 24 to maybe as high as 40 inches, but about 30, 32 inches is pretty standard. And then they blow hot air through this bed of hops from the underneath. And the idea is the hops are about 75, 80% moisture when you harvest them. And if you don't dry them down, they're going to spoil very quickly. They're basically going to turn into compost on you. And the air temperature is usually somewhere between about 135 degrees up to maybe 150, 155 degrees, depending upon, how fast you want to dry them, basically. Okay, so as you dry this bed of hops down, of course, the stuff on the bottom dries out a lot more quickly than the hops on the top. And this process will last anywhere between about 5 hours to 13 hours, depending on the air temperature you use, the depth of the bed, the weather outside, the hop variety that you have, and all of these things are going to affect how long this takes. And when you finally turn off the heat, one of the big problems they have is there's not really any good instrumentation that says, the hops are, average 10% moisture. Now it's time to turn off the heat. And the way this is usually done in the United States is that you have a very experienced grower who reaches down into the middle of the bed, feels the hops with his hand, and says, I think they feel like they're about 10%. So this is a very precise operation, as you can see. And this is the main problem. They don't know when to stop. Okay, and so they tend to, either over dry or under dry. It's really hard to get it right. Okay, and at the end of this process, if you did a very, very good job, the bottom hops are going to be around 5% moisture, which is, 5% less moisture than you want. And the top layer is going to be about 15 to 20% moisture, probably closer to 20%. And very often it's 30%. Okay. So this is, a very, the variability within the bed is just huge. And not only is there a difference from the top to the bottom, there's also a difference from side to side, because the airflow through the bed of hops is never uniform, and it changes every time you load the bed. So this is you have very poor control over the process here. And since you have problems like burning down warehouses, if you don't get it right, this is a pretty critical problem. So the American system its big advantages is that it's a low capital, outlay to build for your operations, and you have very high throughput. But you have very poor control over the process, and that's the big problem with it.
The German tradition for hop drying has a bit of a twist. What's different there?
If we go into the German drying system, there's something here there's two things different that they do in Germany. One is in the United States, the air is heated with either propane, natural gas, or a diesel burner. And the exhaust gases from the burner actually pass through the hop bed. In Germany, they put in a heat exchanger between the combustion gases and the intake air. So it works like the furnace in your home, where the exhaust gases go one way and the hot air goes another way. And this really cuts down on the efficiency of the energy efficiency of the system. And typically, the German system is going to use about 50% more energy to dry the same number of pounds of hops versus the American system. The next big difference is that they don't have just one layer in the hop dryer. There's 3 layers, and you can drop the hops from the top layer to the next layer to the next layer with louvers. And the louvers have, they're basically wire louvers so that the air can pass through. And the idea is you load, instead of about 30 inches of hops, they'll load these up to about 12 inches in the top layer, partially dry them, and then drop them down to the next layer, and you load up the top layer again, partially dry them again, drop them down to the third layer, and you fill up each layer as you do this. And when the bottom layer is finally dry, you pull the entire tier out. It's like a drawer that comes out on rails, and you can dump the hops on the floor to cool, or you can drop them into a conditioning chamber for further processing. The advantages of this process are that you have much less variability from top to bottom in terms of moisture than you do with the American system. You may have the bottom layer might be, well, how should I say? You'll see variation of something like from 6% to 13% or something like this in the moisture gradient, but it varies all over the place. From top to bottom, and also from side to side as you have in the American system. So you have a much less moisture variability with the German system, although you still have more variability than you would like, but it's a huge improvement over the American system. The disadvantage is it uses more heat. If you eliminated the heat exchanger, it would probably be very similar to the American system. But you also still have the problem is, when does the farmer know when to turn off the heat? And basically they're doing it by the same method as the Americans. They have some other gizmos that they use to try and determine when to turn off the heat. But again, it's a very imprecise process. And if you just leave the heat on for an extra 20 minutes, you can go from perfectly dried to these hops are so over-dried, I don't want them anymore.
And that's where you get a lot of the onion and garlic flavor too, as well, right?
Yes. Yeah, that's another thing that if you take hops from the bottom from an American kiln, the hops will very often smell. They'll have this garlic onion aroma, and if you smelled a lot of hops, you know what I'm talking about. But in the middle and top layers, this garlic aroma isn't there, and this is something that. Often you'll find this in hops dried in Germany and the rest of Europe, in other places in Europe where they use this system as well. So you still have this problem of developing this onion garlic aroma that most brewers don't want.
We've also got Bill Arendt on the line. Bill is that guy, the farmer who knows how to reach into the hops and tell you exactly when to turn off the heat. Bill, you're with Hop Haven in Wisconsin, and it sounds like you might have the answer to this problem. What are you doing differently?
We are actually drying with a method that we call AromaSmart. Hop Haven is the name of my farm that I started in 2014. And last spring, I purchased Gorse Valley hops from a group down near Madison, Wisconsin. They actually developed this method, and I fell in love with the idea of the no heat. The risk of fire is greatly diminished because we're actually using ambient outside air to draw our air through the bed of hops, and we start that process. First, our oust is 12 by 24, and we'll put 1 day's pick in an oust, Typically around anywhere from 2 to 3 feet of hops in that oust, depending on the yields we get off the field. There's like 6 sections on the top of this box that open up in an accordion style, basically. And we fill throughout the day, start the air movement, drawing through as soon as we get a layer on the screen bottom. Start drawing ambient outside air through that bed of hops to, start the drying process. And by day's end, we've got our bed of hops laid in there, and our fans are powered. There's 2 25-horse electric motors with 42-inch diameter fans. We're running about 54,000 CFMs of air. Those fans are controlled by VFDs, so we can control how much air we're moving. We'll typically run that ambient air through the bed of hops for about 24 hours. We'll take them from that 75-80% moisture down to around 35%. At that point, we close up the tops of the oust, and we've got a big industrial dehumidification system on it, and we close the ductwork down and start to recirculate dehumidified air inside of the bed. At that point, now the dehumidified air is circulating, and the dehumidifier is removing all the moisture out. There's quite a stream of water that comes out of the dehumidification system. Periodically, we, of course, test the moisture going in, and when we close it, we'll determine that we've kind of plateaued. We've hit a flat spot at what we can achieve with outside air. And what we do is actually use a microwave to test moisture with a pretty basic formula of the wet weight of the hops, and we dry it down in the microwave in short increments of, say, 45 seconds, 30 to 45 seconds at a time. If you go too long, you'll actually start to burn the hops and then lose mass. So it's just a process of 30, 45 seconds at a time until you bottom out, and don't take any more weight off, so you know you've removed all the moisture out of the hops. Then you divide the difference by the wet weight, and that'll actually give you the percent moisture that you're sitting at. So periodically we'll test. It could be at 6 o'clock in the evening, and maybe 3 a.m. Because we're running around 36 hours to dry a batch. When we hit that point at that 8 to 10% moisture, we'll shut off the dehumidification, and depending on the time of the day, if it's 3 a.m., we'll just slow the fans down and keep an air movement going on inside of the vessel, but just stabilize it so that we're not over drying it and not picking up any moisture as well. Wisconsin, of course, is a lot different weather than the Pacific Northwest. After we've achieved that dry weight, we empty the oast with a kill cloth. It's an industrial netting, kind of like with the load handler theory. We roll the oust empty out onto a belt, and we actually put ours into a conditioning chamber, not so much to even the moisture out, but in order to empty the oust out for filling the next day. The downfall to this process, I guess, is that it takes time to do this, and therefore we have 4 ousts that we fill so that we can pick every day of the week except Sundays.
We didn't really talk about blowouts. I mean, that's another advantage of this system versus the other. Do you guys want to talk about that a little bit?
Well, maybe I should do that. This is Val Peacock again. And what a blowout is in the American system, as you're drying the hops down, of course, the hops become lighter. And as they become lighter, they'll tend to get blown out of the kiln if the airspeed is too high. Again, remember that the airflow through the bed of hops is very non-uniform. So very often this will happen in a place in the bed where most of the air is already going through. And when you blow a hole in the bed of hops, it's sort of like a hop volcano, and hops go everywhere. And then when that happens, all the airflow goes through the hole rather than through the remaining hops in the bed. And then you have to throw a piece of plywood over where the hole is. And of course, that's going to give you very uneven airflow through the bed. And it's just, when this happens, it's just a huge hassle for the farmer. Now, the advantage of Bill's system is that the air, rather than going from the bottom to the top, goes from the top to the bottom. So that makes it an air, a blowout impossible. And this is really important because the air speeds that he's using are quite a bit higher than the air speeds that per square foot, I should say, of floor space than the folks out in the Pacific Northwest are using. And to make his system work, you really kind of need to have a higher airspeed, I suspect. So that's another one of the differences between his system and a more traditional system.
Makes sense. Val's recent publication in the Master Brewers Technical Quarterly indicated that thus far this technology appears to be unique to Wisconsin, with several other similar dryers operating in the state. Bill, tell us more about where the technology came from. Are there several of these things out there, or what's going on?
Yeah, so this idea was developed by James Altweiss, who was the founder of the Gorse Valley Hops operation that I purchased. Basically, I had purchased Gorse Valley Hops as a brand as they got out of the business. And their ideas came from James, with the idea that no heat would mean a superior aroma because you're not evaporating off any of the oils with the temperature used in traditional drying. The operation that they had, I think they were on about their 7th prototype when I had teamed up with the Gorse Valley team. And because of my farming background and what we do with cranberries, we've got an extensive fabrication ability here. And I propositioned Gorse Valley Hops at that time to co-op our I guess, knowledge for know-how, what they had gained in knowledge in this prototype drying method, and our ability to put things into full-scale production. And we sat down and got together many times, built our first full-size prototype. Thought, this thing is going to work pretty well, and then refined it a little more and built a full production scale models to allow us to harvest, every day of the week without, lacking a place to put our hops to dry. The airflow determinations, Dan Detmers was part of that Gorse Valley operation. He was the HVAC expert, because you try to figure out what the static load through a bed of hops is, and that's all unknown when you start talking about drawing through a bed of, very moist hop cones. So to reach outside of the knowledge those guys had gained, I was hitting a lot of walls when it came to trying to figure out exactly how much airspeed we would need. So I can't take credit for developing the method, but we definitely put it into a commercial scale, prototype or a full scale model that works very well.
Coming up.
This is an important issue for the craft industry, and it's something that I think brewers should be paying attention to. We want uniformly dried hops. It's important for us for the quality of the hops.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Support for this podcast is brought to you by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
Here's what's coming up on the Master Brewers calendar. District St. Louis meets at Anheuser-Busch January 17th. Is PCR right for your brewery QC program? Check out the Master Brewers webinar January 24th. The District Ontario Annual Conference is January 31st and February 1st. District St. Louis meets February 21st at Third Wheel Brewing, and the 2019 California Joint Technical Conference is February 28th and March 1st in Paso Robles. It's not too early to start making plans for the 2019 Master Brewers Conference. If you can only make it to one conference in 2019, this should be it. We're really mixing it up this time and heading to the Calgary Convention Center to see how Alberta celebrates Halloween. Will there be a costume party? Only Tressa knows. Check out the full calendar of events at MBAA.com for more details or to find a district meeting near you. Now back to the show. Val, listeners can download your TQ article, which I'll also link to in the show notes to see all the data, but this was a thorough study. Talk about how you set up the experiment to compare the 3 different drying methods.
Well, this goes back to work I did 25 years ago, looking at, the moisture profile in American kilns. That work was never published, but this was, one of my chief concerns with the industry, let's put it that way. And then when I got involved with the Hop Quality Group who sponsored this work, we did repeated a lot of this work and built on it. And that's the data that you see in Table 1 of this study. Unfortunately, we never published that. There was a lot more work involved than just what I reported here. But basically, the idea was, as you can see from the chart, you see an awful lot of moisture variability within the hotbed itself. And that's something that we really wanted to minimize. Some of the things we found also was that the oil content of the hops pretty much, was guided by the moisture, correlated well with the percent moisture. So if you had high moisture hops, you had more oil retained than if you had low moisture hops. And this should come as no surprise to anyone. As you heat up the hops and drive off the water, of course, you're going to be driving off the oil. And you can actually measure this. Only this is not reported in the table here. The other thing that isn't really reported here was that the hop storage index also goes up the lower the moisture content. So this was one of the things that we're holding as a quality parameter. We want to retain the oil. We want to keep the hop storage index low, but yet we want to dry the hops sufficiently that we're not going to have problems with storage. So basically, the closer you can get to 10%, the better off you are. You don't want to be below 10%. You don't want to be above 10%. And with the American system, almost none of the hops are at 10% where you want them to be. When you go to the German system, the thing we were looking for in the German system was, is there as much moisture variability in the bed of hops at the end of the drying process? And we clearly found that there was much less variability of the moisture. There was more variability than we want, but it was a big improvement over the American system. We did not look at things such as oil content and HSI in this study. So we were pretty much just saying that if we get the moisture right, all those things are going to be right as well.
But you did test the HSI on the dehumidified system, though, right?
Yes, because it is so different from what you're doing with the other two systems. And this is one of the things that first came to mind. Are we going to have less oxidation because we're doing this at a lower temperature? I suspected we would. From the data that we collected, I suspect that yes, we're getting quite a bit less oxidation. Unfortunately, we didn't have a side-by-side comparison. Here we can dry the traditional way. Here we can dry with Bill's way. And I'd really like to make that comparison if we can arrange that. But as of yet, that hasn't been possible. Of course, when we went through Bill's system here, what I really liked about this, if you look at the numbers in tables 4 and 5 of the paper, almost none of those numbers are more than 2% away from 10%. And to me, that's super. If you look at the numbers for the German system, there were a lot of numbers in there that were, how should I say, much farther away from 10% than Bill's system. If you go to the American system, it's just all over the place. Okay, so progressively you get better performance in the system, going from the American system to the German system to the Wisconsin system. And to me, I'm pretty sure that's going to be a big quality difference. What I would really like to see is if we can arrange to do a side-by-side comparison of the Wisconsin system versus more traditional drying, and see if and actually measure oil content, HSI, and have brewers make hops with the beer and see what they think of this process. From my evaluation of the hops that Bill had here, to me they smelled sort of like normal late harvest Cascade hops without any garlic onion type of aroma. And I know some of my brewer friends are concerned that maybe something positive happens by heating up the hops. From what indications I have so far, I would say that doesn't seem to be the case. But I think brewers are going to have to get a comfort factor with that before they're going to really go crazy about this type of system.
What do you think it would take for large-scale growers in the Pacific Northwest to make the switch to unheated, dehumidified hop drying? There's a lot of infrastructure on those farms, and I'm sure there aren't many large-scale hop farmers who would be particularly happy after seeing these results and considering the cost associated with overhauling their kilns.
I think you're right. This would be a huge capital investment for them. The other thing is that the throughput Bill's system is much lower than the throughput on the American system. The bed size is, how should I say, about half as big as the American system, but that's not the real problem. The problem is, rather than the hops being in there for maybe 8 hours, they're in there for 48 hours. So you need 6 times as much bed space to dry the same amount of hops. And if you have 500 acres of hops, that's really hard to scale up. Yeah. If you have 50 acres of hops, that's doable. If you have 500, at least with the present technology, that doesn't seem like a reasonable thing to do. But remember that in the United States, hop farms are typically 500 acres. In the rest of the world, they're more typically 50 acres. And so for the rest of the world, this is very easy in terms of a changeover for them to make. For American hop growers, it'd be a big deal. Can the technology evolve in the next 5 years so that it would make more sense? My guess is it will evolve in that direction. I'm sure it can be made, how should I say, everything, make the turnover time less, or somehow we can increase the throughput of the system. We can probably make it more energy efficient as well. And so do I expect growers in the next 5 years to put this equipment in? No. 10 years, 15 years from now? Yeah, they should be looking at it and thinking of this as a real alternative to what they have. Eventually, when they need to replace their equipment, that's the time that I would think that it would make sense to really have a hard look and see if this technology is applicable to a big farm.
Great. So Bill, speaking of improving the technology, what's next in Wisconsin? I assume somebody, perhaps you, is busy trying to further optimize the design of the system.
I think that we've really are quite happy with what we've got set up here right now. I'm not sure that we can speed it up, or that we have to. We can harvest every day and turn out quality dried hops. So I'm not certain that there's anything I can do to change the basic design to make it any faster without heat. Keep in mind we never exceed 100 degrees inside of that vessel. The air, when the vessel gets closed, when the host is closed, it's what is called heated compression. And it's basically the air is picking up friction every time it passes over a fan blade. So you do bring your temps up a bit, but they've never exceeded 100 degrees. So, I think that's the key to this method, the AromaSmart method, is to keep the temp low, the drawing the air through the bed instead of blowing it, and to diminish that threat of fire. Was something that was really attractive to me when I toured out in the Pacific Northwest. The kills out there were all built like concrete fortresses, and basically they told me it wasn't if you have a fire, it was when you have a fire. And that's a pretty scary thought for me, to just say, well, we'll plan for a fire. I guess, if I think about ways that you could probably improve this method, the louver system that they use in Germany is kind of a neat deal, because when they open the louvers from the top layer to the middle layer, they're essentially turning the whole bed of hops over at once by the fall. And if there was a way that you could maybe, turn that bed over midway through the process, you could maybe speed up your dry time a little bit, because you do actually get some compaction in our bed of hops because of the suction that's occurring to them. But it does not seem to affect the uniformity of the dry. Air will take the path of least resistance. We do a good job of leveling the bed out, when we're done at the end of the day, to make sure we've got a uniform layer, and the rest of it is just kind of takes care of it. Time does what it does.
Makes sense. Yeah, I was thinking, like, I wonder if there's any way you could sort of, you're kind of going there too, like how you could sort of combine your technology with the German system somehow, so that it did have multiple tiers like that and drop between them. But I don't know, that might be interesting. Obviously, like you said, you don't need that for your farm. And remind me what acreage you're working with there again.
We've got 22 acres in hops.
Okay.
And I've got room to put another 20 acres in. One thing I think that might be important to bring up when Val is talking about 10% moisture is the ideal. I guess the threat of running that line is that 12% moisture could mean composting in the bale. Am I close on that thought, Val?
Yes, that would be a problem, but it's going to be very variable. There are a lot of bales of hops that get stuck in warehouses in Yakima that have a pocket of 12% moisture. And so I think if it really is 12%, you're probably okay. It's because the problem is if you have a bale that's an average of 12% moisture, there's going to be pockets in there that are 16, and then you've got a real time bomb in your warehouse. So what they're trying to do in Yakima is sort of have an average of 10% with pockets that are maybe 12%. That's, I mean, the moisture uniformity of hops in Yakima is just awful. So when they say a bale is 10%, it's
not.
That means parts of it are 12 and parts of it are 8. Okay.
Yeah.
Even after conditioning and having them sitting around for a day or two before they bale them. John, could I add one more thing?
Of course.
Here? So, we were talking about
actually,
adapting.
Before you do that, can I just ask you, when you say that, if they get a bale that's an average of 12 and they're worried that it's high like that, is that when they usually put it in refrigeration?
Generally, it's sent back to the grower, and they say, you deal with this. And the grower may have a refrigeration unit that he can throw them into, or he just may break the bales open, throw them back in the kiln, dry them down a little bit more, and bale them up again. And then when those hops are sent to me, I reject them because they're all busted up. So that's not a very good solution for the grower. But generally, yes, the bale will be sent back to the farm.
Okay, yeah, I just asked that because
the farmer.
I've heard some large scale growers like that talk about putting bales on refrigeration as sort of a Band-Aid, and I wasn't sure if that was the driving reason behind doing that or if there was something else.
Yeah, it's generally that it's a under-dried bale, and they'll throw it in a cold room and let it sit there for a week. And if it doesn't catch on fire by then usually the dealers will be, less concerned about putting it in their warehouse. The bale stabilizes certainly within a week. And all these hop warehouse fires, they've always occurred with, a bale that's maybe 1 or 2 days old. Mm-hmm. The other thing is when they go in the warehouse, they stack the bales together. So the bale doesn't have any place for heat to go because hops are wonderful insulation. And one of the things they'll do in one of these refrigeration units is they'll stack the bales separately. They'll be standing it up so it's got lots of surface area where air can circulate around it. And when you stack them up in a warehouse, that's not possible. Okay. Okay,
great. Go ahead. I interrupted you. What else did you want to add?
Adapting this drying technology to Yakima. One of the big differences between the Midwest and Yakima is in September, the average humidity here is probably 80%. The average humidity in Yakima is probably 25% or something like that. And so you have a huge advantage in drying with unheated air in Yakima because of this humidity difference. If they would blow unheated, or undehumidified air through the hops for 24 hours, that alone, my guess, would bring the hops down to 10%, and they don't even need the dehumidification unit.
So it's totally possible that if they implemented a system like Bill's, that their total drying time might be substantially less than his.
Yes. Also, Bill could reduce his drying time by turning on the dehumidification unit at the very start of the process, because she could dry. You can blow dry air through the hops to dry them, or you can blow wet air through the hops to dry them. And obviously, the dry air is going to dry them a lot quicker. And most of the energy use in Bill's system is the fans, not the dehumidification unit. So my guess, it would actually be more energy efficient to run it with the dehumidification unit on the entire time. So that's one thing to do that would save him some power and, how should I say, increase the throughput of his operation.
Bill, what do you think about that?
Well, we've tried it a few times, and it's there's so much moisture in it at the start that we actually noticed some sweating on the outside of the vessel of the oust, because these are all made out of aluminum, and we actually had some water, gathering at the edges and running down inside of it. And I'm not certain why that occurred, if it was just because they were so moist when we closed it up right away and there was so much water to get rid of that it overburdened the dehumidifier. But, we have on rainy days, we're like, well, it's raining. We're putting wet hops into this. We've got the fans on. Let's try it, But the weather in Wisconsin is so, it's so erratic. It could be 80 degrees one day and 54 the next. So, raining, dry, cold, you name it, we've got to change. And there's no such thing as a conditioning floor in Wisconsin either. We don't drop our dry hops onto the concrete ever, just simply because it would be drawing moisture out of the ground. There's days when the weather changes so much that the concrete floor will sweat. So there's another big difference from piling them on the ground in the Pacific Northwest versus what we do in Wisconsin.
One question for Bill. Feel free to say, no, I'm not comfortable to answer this. But I think a lot of growers would be interested in how much capital investment one of these drying units would cost to construct. Is that something you feel comfortable about talking about?
Yeah, I would think, with our fabrication skills, a lot of it is in-house here. But I think if I wanted to put a price tag on what we've done, if you had a turnkey house built like we've got with the fans and ductwork, you're looking at about probably 25 to 30,000.
Okay.
All right.
And that's, how should I say, that's delivered. And so that's, how should I say?
Sounds like Val's taking orders, Bill.
No, I'm just trying to give interested growers a little bit more information so that they can make an educated decision on this. So
yeah, I'm thinking, if you were to put labor, it's a little different for me to do it on my own farm. Because I didn't really kind of, track the labor per se. I'm building it for my own use. So material-wise, if you were crafty, maybe you'd have, 12 or 15,000 into it.
Okay.
But if you want a turnkey, you're going to be pushing it. And then, of course, the width. The design we have is in 2-foot increments, so you could make it 10 by 12, or you could make it 12 by 24 or 12 by 20 or whatever. But to build it on site, you'd have to assemble the panels and anything over wide, I guess is what I'm getting at, would need to be built on site or transported with a permit.
Yeah, Bill, I was going to ask you about that. Is there any reason why you chose to have 4 separate ones instead of 2 bigger ones, or some other combination of that?
Well, I'm using Wolf 220s from Germany that I had imported here, and I figured my daily.
Those are picking machines, by the way.
Right.
I knew that.
Basic a stationary combine, but I figured my potential for yield on a 12-hour pick day and how much room I'd have to do, how much room I'd need to pick every day. And that's why I went with a 12 by 24, so that with a good yield on the crop, I'd have a place to put it. So that's how I determined why I needed 4, because I could pick every day. By the third day, I'm emptying a vessel, and I can start to fill it again.
Makes sense. Well, Val, I know you're the ringleader of the hop quality group which funded this study, but I'm guessing you probably want to recognize some of the breweries, hop growers, and hop dealers who made all this possible.
Oh, yes, absolutely. I'd like to thank, of course, New Glarus Brewing Company, who, inspired this whole thing. I was up visiting Bill's farm with Dan Carey, and I fell in love with his machine and said, oh, gee, I need to have a better look at this. Also, the folks at Bell's Brewing in Kalamazoo, I guess Galesburg is their official address in Michigan, who actually did all the lab work and everything for the kiln at Hophead Farms in Michigan. And also for the earlier work, from Table 1 that we did in the Pacific Northwest. That was done at Loftus Farms in Moxie, Washington. And the other facility there was the John I. Haas farm that's in Yakima. And they helped us a lot. The Haas folks actually installed a fuel meter on the diesel tanks going into their kilns, so that we get the fuel use that you see for the Citra work in Table 1. We also did some work with Steiner in Yakima at one of their farms, and that was with bed depth and temperature variation, things that were similar to what you see in Table 1 but weren't reported there. And there were a lot of brewers from the Hop Quality Group, from New Belgium and Sierra Nevada and Odell's, and probably a handful of others that I can't remember offhand, and I apologize for that, because that all happened about 5 years ago. But we had an awful lot of craft brewers involved in all that. So this is an important issue for the craft industry, and it's something that I think brewers should be paying attention to. We want uniformly dried hops. It's important for us for the quality of the hops.
That was Val Peacock and Bill Arendt here on the Master Brewers podcast. If you want to learn more, take a look at the data tables in Val's TQ article. I'll add a link to the show notes, or you can get there by typing hop drying into the industry's best search bar at MBAA.com. Want to hear more about the Hop Quality Group? Check out episode 43. Did you know that Master Brewers now has a mobile app? TQ articles, podcasts, webinars, Ask the Brewmasters, and more, all in the same place. Search Master Brewers in the App Store to download it now.
Countdown, I'm moving too fast, and then I hit on the ground. Just like that one day when we came around.